Hello, in this video we're going to look at finding the total surface area of a square base pyramid, but it's actually excluding the base. Okay, so it takes a few steps. So look at this triangle here. How might you find the surface area? What's our goal? Okay, to find the surface area, we're going to need to find the area of this triangle, and it's not as simple as it seems. Looking at what we're given, right? To find the area of a triangle, it's half base times height. So looking at this sloping triangle, our base is 35, that's great, but we don't know our height. That 40 there is to do with this, it's like the vertical height of the actual triangle. It's not a part of this sloping triangle, okay? Now, what we want to do is take a few steps to get there. So have a look at what I've drawn here. We've got lots of right angle triangles in this diagram. There's one on the base, okay? I'm going to highlight what it is. This is our base triangle. And there's a right angle in the corner. And we know that it's a square base pyramid, so we know that that's 35 and this is 35. Now I have drawn this triangle right here. And so I can say that's 35. Now, just trust me, this is the process we're going to follow and it's going to get us more information about that sloping triangle. So let's find this distance. We're using Pythagoras, right? C squared equals A squared plus B squared because we're finding a side length. So our shorter side's 35 squared plus 35 squared, and we're finding X. And so then we just chuck in our calculator, 35 squared plus 35 squared, 2450. Whoops. And that's what X squared is. So X is the square root of that answer. And we're going to do it to a few decimal places till the end, okay? 49.497. Now, so we've used that base triangle there. Now we're looking at this upright triangle. Now let me highlight it. So we've used that base triangle. Now we're looking at this triangle, which is going to correspond to what I've drawn there in that diagram, okay? Now, what do we know about that? Well, we know this distance because we just found it, right? It's this distance, which was 49.47. Actually, this full distance across was 49.497. So this little pink distance here is going to be 49.497 divided by 2, okay? This distance, which is going to correspond with our upright triangle, okay? So 49.497 divide 2. It's a bit of a process, this question. So 24.7485 is going to be this, okay? 24.7485, because we just want halfway across that triangle, half that hypotenuse. Okay, so we got that. And then we can see from that, we can find this green side now. So this is our triangle 2, and we're going to let's call this side Y. Okay. Again, C squared equals A squared plus B squared. Our hypotenuse squared is 40 squared plus 24.7485 squared. 40 squared plus 24.7485 squared. And then we've got an answer and we're going to square root that answer, okay? So that's going to say Y equals 47.037. And I'm going to add that to my diagram, 47.037. Now I'll get rid of that. Okay, so now we know this distance. So let's say 47.037. I'm going to get rid of that. Now we've got some more information about our sloping triangle, right? Which is nice. So our sloping triangle is this thing. Our sloping triangle is this one, which corresponds to this. We've got a bit more information about it. We know now what this side length is, 47.037. Now, what's the rule for area of a triangle? Because that's our goal, right? We want to find the amount of material needs to cover. Material means area. Area of a triangle, just thinking about it, is base times height divided by 2. And it's important to know that's the perpendicular height. That h is the perpendicular height. We don't know that yet. So, how do you reckon we can find that h? Okay, look at your thing. This full distance across is 35. We know this distance. So let's draw another diagram. We're going to split that triangle in half and we're going to see that there's a right angled triangle there. And it's got 47.037. What's this distance? This distance here? Well, it's going to be 35 divided by 2. I don't need my calculator for that, but I have. So this is 17.5. Be careful at that step. And this is h. So once again, we are using Pythagoras. So I'm going to say we need perpendicular height. So first need perpendicular height, and Pythagoras once again. Lots of practice. So hypotenuse squared. So this time we're substituting in this hypotenuse, and we've got the two shorter sides. So h squared plus 17.5 squared. Now, how do we rearrange for h squared? We need to get that 17.5 squared over the other side by subtracting it. Okay. Chuck in your calculator, 47.037 squared. Take 17.5 squared is 1906 point something. I'm keeping that on my calculator and square root answer. So h is 43.660. That's the perpendicular height. Now I'm going to label that in, and we're coming back to this main diagram. So this is now 43.660. We're nearly at an answer. So we come back here, and we've got our perpendicular height now. We've got our base is 35. Make sure you're using this triangle and not this one. So we can use it. Area is base times height divided by 2. Base is 35 times the perpendicular height divided by 2. $764.05. Now, the thing is, we come back to our question, because at this stage we might have just forgotten what we're doing. We're finding the square base pyramid's area excluding the base. We've found the area of this triangle, so we've just got to times it by 4. So keep that answer in your calculator and say surface area is that times 4. 3056.2. Now, what units would that be in? It will be in square centimeters because we plugged in centimeters. We're going to get areas square centimeters. Now we check the question again for the number of decimal places and the units. It says answer in square meters. So, how do I get that into square meters? Well, centimeters to meters, divide by 100, but we want centimeters squared to meters squared. So we're dividing by 100 squared, which just means move the decimal 4 places to the left, because 100 times 100 is 10,000? Hang on. Yeah. Okay. And yeah, what do we got? 0.3056. And to 2 decimal places, that's going to be 0.31 square meters is the surface area. So just a quick recap of what we did. I mean, it's about 4 steps, right? We looked at, we realized, okay, our goal is to find the area of this triangle and then times it by 4, but there's a lot of missing information. But we can just take it one step at a time. We found, using this base triangle, we found that diagonal length. Okay, then we split that diagonal in half so that we had some information about this vertical triangle here, which is also a right angle triangle. Okay, and then, so we had some information there, that pink thing, and we can now find this bit of information about our sloping triangle. So we found that bit of information using Pythagoras once again, but then we come back to our formula, area base times height divided by 2, and we realize we need the perpendicular height. We're given this slopey height. We need perpendicular height for area. Find it again using Pythagoras, and then you're good to go. Make sure you check decimal places and units at the end. So I hope that helped. I will see you in the next video.